Hello, everyone. Good morning. Welcome to this new session where we are going to talk about BEA. The title is New Virtual Sensors for Vehicle Access Automation. Art, welcome. Good morning.
Hey, good morning, Miguel. How are you?
I'm fine. And you?
Great, I can't complain. Pleasure to be here with you guys.
Perfect. And must because it's Friday, right?
Absolutely. I'm sure everybody here can echo that sentiment.
Perfect, Art. Well, let's just wait about a couple of minutes so everyone can join and no one can missing any information that we are going to share with them.
Absolutely.
Just to let our customers know, just to remember that we have three branches. We are located in El Paso, Texas, San Antonio, Texas, and in Miami. So if you have a project or any concern, you are welcome to join us in our branches or contact your sales agent, and we will be very happy to help you. Art, I think we can start now.
Okay, great. So thank you, EPCOM. Thank you, Miguel. Thank you, everyone, for being part of this webinar this morning. We are grateful for the opportunity. For those of you that do not know who BEA is, BEA is a European-based company that was founded in Liège, Belgium. We are actually celebrating our 60th year anniversary this year. BEA was founded by a gentleman, a Belgian industrial engineer that goes by the name of Fernand van Genneken. And 60 years ago, he was curious and fascinated with the technology of microwave, specifically the Doppler principle. So he invented, as a result, the first microwave motion sensor for an automatic door. That is how BEA was founded and formed. And I like to share that story because it defines who we are today, 60 years after. Prior to the invention of the microwave sensor through BEA, the most common way to activate a door was through a mat. So you would step on the mat and it would trigger the opening, the activation command for an automatic door. So we're very prideful of our origins and how we were founded because it was a disruptor. It changed the game of the automatic door industry. Till today, you go through any opening and you will find a motion sensor, whether it's a BEA or not. And over the 60 years, we've evolved into a very highly specialized sensor company for entrance systems, access controls. And you will find us in many different types of verticals, which I will share a little bit coming ahead. But those of you that do not know us, that is our origin. Me particularly, my name is Art Ortega. I am based in Southern California. I have exposure to the domestic U.S. market with some responsibilities as well that encompass the international arena. So, with that being said, we'll go ahead and get started and share a little bit more about BEA. These are the types of technologies that over the 60 years we've exploited, developed, researched with the fine objective to be able to detect people, vehicles, objects in a means of creating a safe and convenient automated world in the entrance system sector. So some of the technologies that we've exploited have been radar. We use microwave through the means of Dopplers or FCMWs. And radar is most commonly used for us as a means of opening command, also known as activation. We use it primarily to trigger an opening command, whether it's an automatic door, a gate, or a barrier arm. We don't really use it for safety that much, but we tend to use other technologies such as infrared. Infrared is a presence detection which allows you to have continuity of detection infinitely. It uses a triangular pattern. For those of you that are familiar with gates, you may often use photo beams for UO325. And the photo beams, you use the triangulation pattern, which is you have the emitter that emits the light beam to the reflector, and then it reflects back to the receiver using that triangulated pattern. We use that triangulation principle as well, but in a vertical approach rather than a lateral approach. and we remove the reflector and we use the floor as a triangulation method for means of detection of people. And so as long as you are disrupting the infrared pattern, we give continuity detection, and it's a very effective way of creating a safety pattern for human and vehicle detection. And lately, and we've been exploiting quite a bit of laser. It's worth mentioning that at least in the vehicle access control arena, BEA is probably the only manufacturer today that offers laser solutions for means of vehicle detection in entrance systems. And the advantage of laser is it's very high resolution, so it's a very focused point, and we're able to deploy paints curtains that are saturated through these resolution spots for the purpose of either triggering opening and presence detection in vehicle applications, such as gates and barrier arms. This has been a true game changer for us, and what we've seen in the industry, it has been embraced very well through, the definition of the technology that's able to bring and the precision and reliability. So in the coming slides and coming products, I'll be able to share with you some of our latest and greatest sensor platforms with laser technology for vehicle entrance sector. But before we go into that, these are the verticals where BEA participates today. The blue is the origin where we started 60 years ago, which goes to say it's in the entrance arena for automatic doors. So today, if you go through any automatic door opening in your convenient store, your hypermarket, your airport, your hospital, there's at the very least a 40 to 45% chance that you go through any of these openings in the States. It is actuated through a BEA sensor. Then we go into the red arena, which is industrial. Industrial encompasses high-speed doors, rolling steel doors, docks, and really any type of opening or entrance system that you can run across a distribution center, factory, and so on. So we'll actually touch a little bit upon that towards the end of the presentation. And then the orange is where we're going to be focusing the purposes of this presentation, which is vehicle access control, namely barrier arms, gates, vehicle classification, parking. And lastly, we touch the green, yellow, and purple, which is, you know, PTS, known as public transportation systems, perimeter protection, such as intrusion, safety for through the means of laser technology, and lately what's been machine safety operations, such as AGVs and factory operations where you need means of detections for the purposes of safety. So those are our verticals today. We'll go ahead and focus on what the purpose of the presentation is. And just to give you a broad scope, these are some of the customers that have used BEA, that have BEA in their openings all across our different types of entrance system solutions that we offer. Home Depots, Bose, McDonald's, Kmart's, Lowe's, you name it. Most of the Forest 500 companies, transnational companies, one way or another, either have our products spec'd, have them on their openings as a means of opening and safety, and we take great pride in that. So the purpose of today's presentation is to walk you guys through a little bit of our range of offering solutions that have to do in the vehicle entrance arena. And when we talk about the vehicle entrance arena, we're really focusing on some specific applications, namely gates. When we talk about gates, there's sliding gates and swing gates. And so we are targeting these types of gate entrance applications as well as barrier arms and parking applications. Um, the solutions that we want to bring to the light are innovative, meaning they've been developed and used in the last couple years. I can't go on to talk about our solutions without first bringing up the most common way of how to detect a vehicle today in a gate or barrier arm, and that's through a loop detector. So, I always say the loop detector has been around for quite a bit of time. If we look at the cell phone product life cycle, it's fair to say that the loop detector has lived through the first invention of the cell phone, the Nokia, the Motorola, the Nextel, the first invention of Steve Jobs' iPhone, up to what it is today, the iPhone 16. So it's been around quite a bit. And that's because it's reliable and it works. But over time, we've come to learn that technicians and installers would prefer if there is a reliable alternative solution that could get them away from cutting the floor, depositing a loop, sealing it, and running it up to the gate operator. In addition to that, in some parts of the states, we actually see laws that are being implemented. For example, here in California, where now you are to accumulate the waste that the floor cutout produces, and you are to inventory it, and then once a week or once a month, you have to pay for a specific service that comes and picks up those waste, so it doesn't contaminate the environment. So we could see that kind of spreading more over time. And then, of course, there's always those challenges of picking up vehicles that may not equally have metal distributed along the profile of the vehicle, such as big rigs, motorcycles, or even lifted trucks. So we've come to realize that there are plausible pain points associated with the loop detector. And so as a result of that, here are some challenges that I kind of bring to the light over time. And these are all done here in the States. The one on the left is a residential application on a swing gate. You could see the floor layout, and it's very obvious that the property owner did not want to have a shadow loop um, laid out on the floor. So they were looking for alternative means to create safety around the motion of their swing gates. Then you have ranches, which I know in Texas are very popular, and sometimes they're quite a bit away from the city, and you might not always have the best conditions in the floor to consider a loop layout. Asphalt is very popular, but as we all know, asphalt deteriorates over time, cracks, and once it cracks the sealant of your loop, you have, rain season come around, and all it takes is a few drops for the water to practically and essentially damage your loop detector, and you'd have to reconsider reapplying the loop. And then lastly, you have, your wiring cables, and this is more of a beginner's, but it did happen in the field, and that is why I took a picture of it. They ran the loop in a tube that runs 30 feet together with 110 and 220, and they were wondering why they were having troubleshoot problems with their loop detector. Um, so evidently that was an interference problem. So these are all different types of challenges that can arise over time with, the condition of the floor layout, the condition of the application, the condition of the wear and tear, or the infrastructure of running wire and cable. So taking that into mind, we decided to develop and exploit laser technology about 16 years ago. When we first launched it, it was very expensive. Over time, we've been able to mature the product, economize it, reach economies of scales, and be able to present new platforms of lasers that are more price attractive. But the laser is a very different means of technology than a loop detector. We know the loop deploys an electric magnetic field, so when it picks up metal, it diminishes the inductance of the loop detector itself, and that's how detection occurs. In a laser, we're emitting a spot, which is 905 nanometers, and it's shooting out planes, which in this case, it is four planes. The total spots that is producing as a whole over those four planes are 1,048 spots. That roughly divides into 263 spots per plane. And it allows us to project planes. In these planes, we can program them up to a maximum capacity of 10 by 10 meters, which is the same as 30 by 30 feet. Um, and in the coming slides, I'll be able to kind of show you the pattern, which is very different in a loop or a radar microwave flow. The sensors work really great in such in environmental conditions such as rain, fog, etc. And the housing of the sensor is NEMA 4 IP65. NEMA 4 lets us know it's rated for industrial environments, accumulation of dust, particles. And IP65 lets us know that it's resistant against water pressure specifically. So, when we talk about outdoor environments such as rain, fog, the housing is structured to support those types of conditions. It cannot be submerged in water, nor do we care for it to sustain operations when it's submerged in water, but we certainly do care about it being resistant against rain, thunderstorms, and things of that nature. So I would like to introduce everyone to our LZR H100. The LZR H100 is a laser-based sensor that is an alternative to placing a loop on the floor. It creates two zones, if you can look at the image. The green zone is the ability to filter out people and only detect vehicles. That is your free exit zone. And then you have your red zone, which is your presence zones. The presence zones is designed to behave similarly to a photo beam or an edge, which but a non-contact solution, meaning that we don't want the gate to come anywhere remotely close in contact with an individual or a vehicle. Each zone has its own output, and you have the ability to program each zone within the scope of 30 by 30 feet. The sensor is mounted anywhere between 15 to 20 inches from the floor in a horizontal shape. That way, when the vehicle is approaching the pattern, what occurs, it saturates and it picks up the uniformity of any profile vehicle, and that is the front tires and the front bumper. The sensor is compatible with any type of gate operator or barrier arm manufacturer out there. It feeds off of 12 to 35 volts DC, and it operates through solid state relay outputs. So here's a brief video of the H100. So the car approaches the pattern. The green pattern is your free exit for your open command, and your red patterns are your presence, making the installation very simple and easy. So we talked about two zones, the red and the green. The green zone is our free exit zone, which has the ability to ignore or filter out pedestrian movement. It's worth mentioning that that zone can be either momentary or maintained. Momentary means a momentary pulse. If you're trying to enable it for a trigger, such as a card reader, and double validate with the card reader, that's a vehicle with the card access entry for the gate. Maintain it's like a loop, meaning that as long as the vehicle is in the pattern, it will hold the relay infinitely until the vehicle exits the pattern. One of the cool things of the laser is it has directional approach, meaning that we could filter out cross traffic. If a car approaches the sensor, but it's not intending to head into the gate or in the direction of the sensor, we could reject that cross traffic. And that's a very great dynamic that the loop cannot feature. The loop is just present, it's looking for metal, irrelevant from which direction it's approaching. Whereas in contrast, here we have the ability to enable cross traffic filter. We could also make it unidirectional, which means it's only looking at picking up motion in the approaching side of the gate or the sensor, or bidirectional, which means it's only looking for motion that is entering or exiting the gate. It is a very user-friendly sensor. I believe that, on average, an installer can mount it and program it in less than an hour and a half. And that's kind of going quite the waste. Once somebody becomes very skillful with the laser, they can really install it and program it in less than 30 minutes. You don't need two people at the job. You don't have to cut out the floor. And you get to complete it in a much shorter span time than a loop detector. This is a wiring layout of the laser. So it is a 8 wire conduit. You have your red and black, which is your power. And again, it feeds off of 12 to 30 volts DC only. If you have an AC alternate current gate operator, you will need a power supply to not only rectify the power, but filter and regulate it. And the reason is because you can see the bottom blue cables that are connected with the power. And those blue cables are our test cables. Most of the time, those test cables do not get landed directly to the gate operator. So as a result of that, we have to land our blue cables with our power cables, and that is the reason why we need a power supply. Um, In some gate operators, you might have filter regulator power coming directly from the control board. And if that is the case, then you do not need a power supply. Then you have your two outputs, your relay one and your relay two. Your relay one are your solids, which is your solid white and your solid green, white being your common and green being your contact. And then you have your second set of relays, which is your red zone, your present zone, and that is your stripes cables, that is your white with black and your green with white. White with black being your common and green with white being your presence or your normally closed circuit. Through a remote control, you are able to reconfigure these outputs, meaning that by factory default, relay 1 is normally open and relay 2 is normally closed. But if your gate operator is normally open like a lift master, you have the ability through the remote control to just flip them over to both be normally open. Um, so they're very easy to reassign. And the orange cables are not used, so those are usually done for internal purposes such as firmware updates and things of that nature. Um, so we can move right along. So now we know a little bit about the overview of the sensor. We know it's an alternative to a loop. We know it uses laser instead of loop. We know that laser gives us quite a bit of advantages, such as, not having to cut anything out on the floor. We are not looking for metal density. We're using laser planes that are saturating and detecting the approaching of the vehicle. We know that we are able to use motion to, direct the approach of how we want to pick up the approaching traffic. And so, being conscious of all those things, here are some of the applications where the lasers kind of really bring light. So, a common one are big rigs. And what happens with big rigs is that, and I'll show the video as I'm explaining it. You could see that the big rig, the truck itself is low profile and it has enough metal density. But here comes the big rig itself, and you could see just around there, I'm gonna pause it, that here's the loop, and here is the big rig. You have much higher altitude height between the big rig and the loop, and you don't have as much metal density. So what ends up happening sometimes is that the arm will come down. And when the arm comes down, the big rig itself will take the arm out. And that is an expensive pain point because once the big rig takes the arm out, it's pretty expensive to replace the arm, the motor. So some people have tried putting photo beams, but then you have this problem over here, which is the separation between the big rig and the truck. And it's just enough for the arm to come down. It's just enough there for the arm to come down and still take it out. So the advantage, and sorry, I'll go right back. The advantage of the laser, which is mounted on this arm here, on a Dorking arm, is it allows for it to pick up the continuity because you have 30 by 30 feet. That's not to say we're using the 30 by 30 feet, but we have the ability to give continuity detection. We're not looking for the metal substrate. We're just saturating these four planes, these 1,078 spots for about 10 feet out to give continuity detection between the truck and the load and ensuring safety along the trajectory so that it doesn't drop the signal and the arm has any minimal probability of coming down and being taken out by the big rig. So it's really an investment protection. It protects the longevity of the arm. Here, what we're really trying to protect is the arm from coming down and being taken out from by the big rig. Next, we have shadows. So we know there's a lot of gates in California, and a lot of them are swing gates. You have your 12 footers, 18 footers, 25 footers, even 40 footers. And we know shadows sometimes can be a hassle. You have to lay out the loop, you have to run the cond over to the gate operator, land it on your shadow safety and so on. So the laser can be an alternative. This is a 25 footer. And in 25 footers, what we've seen is you're either going to deploy a large loop, which can be subjective to interference and sensitivity, or you could place two 4x6, which at that point you also have to be a little bit worrisome about crosstalk between both of the loops. So the nice thing about the laser is because it gives us 30 by 30 feet, we can have one that saturates that entire 25-foot opening. And we run liquid tight down to the gate operator and landed directly on shadow, which means that it's going to be exercising the same logic. That laser is only going to come on under two conditions, and that is when the gate's fully open and when the gate's fully closed. And it's going to saturate that 25 by 25 foot threshold pattern to keep it active while cars are coming in and out, or golf carts or motorcycles, etc. You do see two lasers on this job site, and that is because this is a two-way traffic swing gate, meaning that one of them is looking specifically into the threshold pattern for the shadow safety, and the other one looking towards the stop is our free exit, meaning that as the vehicle is approaching that stop, it's going to trigger the open command. Once it reaches a full open, then the car can go, and then the shadow's active so the gate doesn't intend to close while there's cars going through the threshold. So this job site was done in about an hour and a half, much less than what can be considered a loop. Another cool application that I'd like to share with you guys is an interlock between a barrier arm and a sliding gate. So we know that here you can see a very small gap of about 5 feet from where the laser is, and it's facing the front of a sliding gate, which is opening and closing. And I can run the video here. You could see how the sliding gate is closing, and the laser is literally right in front of it, 5 feet away. And the advantage of the laser is that it's very precise. So that is to say that we ran a pattern field size that is 5 feet, and it doesn't go a single inch more than that. And that is very important, at least for this application, because if it sees a gate, then that's going to be problematic. That's going to trigger the gate to recycle and goes opening and close all day. And that's evidently not a reliable solution. But with the laser, because we can define the field pattern and tell it where to stop, very different than the microwave lobe or an electric magnetic field, we can define this very great precision where this gate measures 12 feet by the 5 feet depth, and we're using it as a down. So once the car clears the laser, that DKS barrier arm will send it to come down. So the ability to reject cross traffic, the ability to define patterns that are small, large, that are fitted just for the application, and it doesn't see beyond that is very important. And that is, one of the areas that, in this type of job, which is the Chino Airport in California, really highlighted the application and brought a solution to something that was very small and confined. Here are other H100 application job sites. I kind of want to broaden the application scope and reach of the lasers. They work with swing gates, free exit. You could see here a parking grill. This is a 25 footer. It's sensors mounted on the post. Sliding gates, two-way traffic. We have one on each side on a commercial parking lot. The one on the far left is a school, private school in Culver City. The sensor's actually mounted inside this yellow pedestal post, and it's a 12 footer. And it's being used for both free exit and presence in the proximity of the gate. So these are all different types of mounting applications. You could see how installers use different types of mounting profiles and brackets to adapt the sensors to different types of fitted applications. The school evidently could be subjected to vandalism, kids playing with it, so it was evidently recessed inside a pedestal. So you could see here quite a bit of a broad range of different types of entrance systems where the laser really kind of stands out. So that is the H100. Now I want to talk to you about the LZR flat scan and I-30. These are presence-based laser scanners. Unlike the H100 that has two zones, the green zone, which is your free exit, and the red zone, which is your presence, the flat scan and the I-30 are presence-based sensors, meaning that they only output the red field. As a result, because it is presence in presence only, we have a little bit of more versatility. And the reason that I bring up this image here is because you can see that now the pattern is in a vertical format. The flat scan S, which is the one on the left of the picture, is a sensor that outputs a field that is 18 by 18 feet maximum. The one on the right, which is the I-30, and it has the same hardware platform as the H100, is 30 by 30. Both sensors have two outputs, meaning two relays. They are both NEMA 4IP65 for outdoor, and a unique versatility of the lasers here that the H100 does not have is it could be mounted both vertical or horizontal. We could use them on gates, barrier arms for vehicle access controls, and even tolls for mobility solutions. So here I'd like to kind of bring to the light the versatility of how we can either mount this sensor in a horizontal or vertical approach. When we put it on the vertical, which is on the image on the left, we can observe that we are running it adjacent to the dimension and perimeter size of an opening such as a sliding gate. So we have the ability to project the same perimeter layout as the threshold with no dead spots, ensuring absolute presence in the front of the threshold. On the right, we have a horizontal layout similar to what we saw with the H100. Only difference is we only have the presence field. The advantage of placing it in a horizontal approach is you have much more presence from the face of the barrier arm of the gate. So it's picking you up further out. Both have their application usage. This is the wiring layout. It's a little bit different than the H100. It does have European colors. We do plan to go into the US coloring code here pretty soon. But for now, our green and brown are our power. And similar to the H100, it is DC only. We have our first output, which is OptiFET, which is our white and yellow. And then we have our second output, which is a Form C relay, which are our gray and pink. Evidently, in the flat scan S, we only have one plane, which means that we can only land it to one output, which is one or two. But it does give us a little bit of versatility, which I will show a little bit more in the coming slide. And lastly, we have the red and blue, which are our test cables. Those red and blues get landed with the green and brown of power. So here's a job site over in LA. It's actually the entrance of a big large gate company called Automated Gate Services or West Coast Gates. And you could see two sensors on this gate. The one in the right is in a vertical format, which is at the very top, and it's deploying adjacent to the face of the opening. And then the one on the left is horizontal, which is picking up much further distance from the face of the gate. One of the cool things about this sensor is we know we have one plane, but we have two outputs. So what ends up happening sometimes is that you may have people homeless that live in the street and may do things to these gates like try to cut the chain off to have entrance into the premise. So one of the things you could do with these lasers is you could use one of those outputs for your direct presence, reverse, or safety on your gate operator, but you still have another output. And so what some people do is they land it into a timer with a siren. And say, for example, the operating office hours of this location is from 8 to 7, but from 10 a.m. to 5 a.m., a timer will kick off and it'll enable the second relay. And that second relay will be tied to a siren. So that is to say that now the sensor is exercising two functions 24/7 presence in front of the motion of the gate. But during the off hours, if somebody tries to cut the chain or jump the fence, it is a safety perimeter. It is an intrusion alert, and it'll trigger that siren to come off in the event of somebody trying to cut the chain or jump over to the premise. So that is a nice feature of having two relays tied to one specific plane. You have the ability to multifunction the sensor. Here's a nice job site application that I like to showcase because it's a nice game changer. We know shadow safeties can be laborsome, and we know that they don't always work the best because they could still sometimes pick up the motion of the gate, meaning parts of metals of the gate layout, and it could be problematic at times in many instances as the gates now in motion. That shadow comes off and it could still catch a car that's piggybacking. If it's a golf resort, these golf carts go around it and that could be troublesome or dangerous. So the nice thing about these sensors is you could see that there's one mounted on the very edge of every gate leaf. And here I'm going to trigger the video to come live. You could see how the gate starts opening. And these sensors, since they are mounted on the leaf of the gate, they're active during all the conditions of the gate cycle, meaning opening and closing. And if a car is to approach that, or a person, it'll interrupt the presence of the plane and it'll recycle, it'll reverse the gate, minimizing the possibilities of that gate coming in contact with a vehicle or a person. So this is a great presence alternative for these types of applications because one, they're very simple to install. They're mounted at the very edge of the gate. And two, and most importantly, they're active during all the conditions of the gate cycle. Opening, open, closed, closing. So it gives you optimal presence during the most critical times of the gates, which is cycle, which is when it's in motion. Here we could see the sensors mounted on a parking application swing gates. So you have one on each side. This is an 18 footer, and one of them is specifically for the entry, and the other one is specifically for the safety. Here's a little bit of a different type of swing gate. So this is done over at the Frito-Lay's distribution center in Rancho Cucamonga, California. And here we have the I-30. The difference between the I-30 and the flat scan is the I-30 outputs four planes. So you have a little bit of more safety depth from the face of the gate. It picks up about 2 feet from the face of the gate. And this is an 18 footer. And what was happening here are this was a big rig exclusive entrance. And the big rigs were taking out the gate. And every time they took out the gate, they were beating up the arm. And every time they beat up the arm, they beat up the motor. So they were looking for some type of shadow interruption that will minimize this from happening. So we put an I-30 on the swing gate. So as the gate's in motion and a big rig is approaching, it'll reverse the cycle, minimizing the impact between the gate and the big rig and improving the longevity life cycle of that gate, its arm and its motor. Here are other flat scan S versatility applications. You can see how it's mounted on the swing gate for motion. You also have one that it's mounted on a post in a horizontal approach facing the swing gate for shadow, meaning that this is only active when the gate's fully closed and it's looking into the threshold of the swing gate, both commercial and residential applications. So just to illustrate, the flat scan in the I-30 can be mounted vertically. It deploys a vertical plane or horizontal, and depending on the resolution of the sensor, it gives direct continuity detections as long as it's picking up through the plane field that it's projecting. These are some of the accessories, some of which are essential, some of which are optional. One that is essential is the remote control. The only way to program the sensor is through a remote control. There are no pods, no dip switches, no mechanical, well, there are minimal mechanical adjustments, but for tilt and angle. All the programming is done through the remote control. The most common mounting accessory is the one right underneath the laser hardware, which is the laser bracket accessory. That really allows you to mount the sensor on gates, whether it's swings, sliding, even barrier arms. These are a little bit more industrial types of arms that put the sensor a little bit further out. We really don't see these engaged in barrier arms, but we might see them a little bit more on industrial openings such as doors like hangar doors, rolling steel doors, high-speed doors. This is a little bit more of a robust housing enclosure that houses the sensor inside, and it has an L reach to position the sensor for certain capacities. And at the very bottom, we have our power supplies. We have a range of power supplies that we can feature in the event that you need the power source to transform and not just rectify it into DC filter regulated output. Lastly, I want to introduce the wide scan. The wide scan is a overhead sensor. So all the sensors we've seen are been either horizontal or vertical. These sensors are overhead, meaning that their pattern projection are depending on the mounting height. The nice thing about this wide scan, it deploys three patterns. One of them being the safety, which is the red, then the green, which is the motion, and the yellow, which is presence. These patterns can be highly configurable and reassignable. The sensor can be mounted all the way up to 21 feet off from the ground. The pattern deployment that you see here in terms of width and depth are a 1-to-1 ratio, meaning that if you mount it at 16 feet, it's going to give you a maximum of 16 feet width by 16 feet depth. From there, you could downsize the pattern, make it smaller, but it is a 1-to-1 ratio. The sensor is NEMA 4 IP65. And the nice and cool thing about this sensor is you can program it through an app, which makes the programming experience very intuitive and user-friendly. You can use it for parking integration, vehicle access control, high-speed doors, and or commercial and rolling steel doors. So here we see it at a dealership, which is a very common application for these sensors on rolling steel doors. It allows for a continuous flow of vehicles coming in and out of the openings, optimizing also presence in the proximity of the danger zone where these doors are coming in and out. So we'll go ahead and talk a little bit more about the laser. One of the unique features in applications of this are dock applications. So some of the unique features of the dock application is in the presence field, which is the yellow field. We do have a filter height object. So not only are we able to conventionally discriminate or filter out people for it to only pick up vehicles, but we could also reliably detect just the big rigs because we can put an object height filter, meaning that if it doesn't meet a certain height criteria, it will not see it. So that way, when a big rig's backing into a dock, it'll only trigger a detection alert when it is met at a certain height criteria, and we can discriminate vehicles that are below this height criteria. So when we're going to inflate the seal, when we're going to enable the ramp, we want to make sure that it is an actual big rig that is approaching and not any other type of vehicle profile. We also land these sensors with traffic light indicators that can allow the driver to know when he is perfectly positioned right underneath the dock. It is a maintained contact as well, not a momentary motion contact, so that it can give us an infinite detection pulse and sustain that pulse for the traffic light indicator and the sealant in the ramp. Here you could see parking applications. So these are parking grills in multi-level parking stations for condominiums. And you could see here the sensors mounted at the very top, so it's not subjective to being invaded. I am testing personally here the safety field. So as I'm approaching the proximity of the opening, the safety field picks me up and it reopens the gate on the parking grill. And because I have three zones, I can enable one for my opening command, the other one for my presence, and the last one for my safety. And that is a very nice feature to have in these types of applications to give continuous flow detection, to exercise different features, such as your opening command, if you want to be able to minimize the parking grill from coming down in a close proximity, you are able to reassign these features. Here are other vertical applications that the wide scan is also known for, such as bifolding doors and fire stations. So this is a fire station right in the center. It's a nice picture, but you could see the wide scan up here on the post. You have cold storage applications. In cold storage applications, you get a lot of condensation dynamics. You also have a perpendicular setting here where you have one door with the other that can overlap patterns. And the nice thing about these lasers is you can tell them where to stop so they don't overlap each other and crosstalk to each other, which is one of the challenges they were having here that they were able to fix with the wide scan. We actually made it a case study. It was a large brewery manufacturer over in Wisconsin. They're very common also in high-speed doors and commercial rolling steel doors because they're overhead and they can define a very large depth pattern to pick up the approaching motion from a considerable distance. So these are just some of the other vertical applications where the ride scan really brings value. I also mentioned that the wide scan can be programmed through Bluetooth. So I'll let this video run real quick and then I can talk a little bit more.
From now on, with BEA's app, setting up and configuring the sensor is a piece of cake. Connect to your sensor via Bluetooth. Launch a teach-in and view your field settings. Adjust field configurations with real-time visual feedback. Learn up to 3 virtual pull cords right from your smartphone, and much more. Download it today on the Apple App Store and Google Play Store.
So you could see that there are quite a bit of features, and that was a very pretty high level video. But the app really kind of brings to light the experience of how to program the sensor because everything's done intuitively. You could downsize the pattern, increase it, enable zones, deactivate zones, and it's all done in the finger touch. You also have visualization patterns that allow you to see in real time the size of your pattern. And you also have object enablers that allow you, if you walk up towards a pattern, for you to define what the sensor is seeing. So this makes it very practical for installation, for programming, and even, and more importantly, troubleshooting.
Yep.
So
LZR wide scan. The LZR
we'll go ahead and move on over. The last one that I want to show you is Sensor has a feature called the pull cord. And here is a Amazon job site where the pull cord really came to light. They have AGVs circulating through these openings. And one, it was important for the sensors to reject cross traffic, meaning to not pick up the AGV if it's just circulating through the hallway. But we do want it to see when the AGV is intending to go back into its inventory storage location. So here you could see the door actually opens, and that is because the wide scan will learn after a certain seconds how long that AGV is there for, and it'll trigger the door to come open. And if there's people or AGVs walking through the hallway, we don't want those doors to open. So we were able to create a nice crafty solution for Amazon through the features of the wide scan. There's quite a bit of nice features behind them that allows us to create a range of solutions. So with that, we're coming to the last couple minutes of our webinar for today. So just to kind of bring a comparison outlook of the three types of sensors that we covered today. The first one was the H100, which features two zones, the sensors mounted in a horizontal approach. It's ideal for gates, whether they're sliding or swing gates, barrier arms, and other type of entrance systems. The green zone can be used for free exit, and the red zone can be used for presence. Then we have the flat scan in the I-30, which are presence-based only, that can also be used for gates, swing gates, sliding gates, barrier arms. The nice thing about the flat scan in I-30 is you can actually mount them on swing gates and they can project you patterns in all conditions of the opening and closing cycle, which is a very nice dynamic because it is the only sensor that can do that today. And then lastly, the wide scan, which is our overhead laser scanner that we can use in parking grills, commercial rolling steel doors, high-speed doors, and it is a volumetric pattern that gives us quite a bit of detection range from a width to depth perspective into three zones, which is free exit, presence, and safety. So with that, I'd like to conclude the presentation. I'd like to once again thank each and every one of you for joining our webinar today. I also would like to thank Miguel and the EPCOM team for giving us the opportunity today to be part of this platform and present our technologies. I'd like to leave it open for the last couple minutes should anyone have any questions, observations, comments. They're all very welcome. So yeah, I'll be here for any questions that you may have.
Thank you, all. Actually, it's my pleasure. Thank you so much for joining us today and share all this valuable information. As you said, we are going to give a couple of minutes to see if anyone has any questions. But I just want to remind you, if you have any project or any sales, you are welcome to send me an email, and I will work together with Art to see what we can offer to you to close your project or to offer more solutions to your customers. So, Art, I don't see any questions here on Zoom or YouTube or our webpage. So, I think I just want to wish you a great weekend.
Thank you, Miguel. Have a great weekend as well. Everybody that joined us, have a great weekend. And thank you once again. And like Miguel mentioned, if there are any projects, applications, or job sites that you feel are fitted for these sensors, feel free to reach out to your sales representatives. And we, from a manufacturer perspective, work very closely with our partners and we can collaborate and support any type of job site installation that can require these sensors.
Thank you so much, Art, and see you in our next session.
See ya.
Bye.